So now we're going to talk through the beginning idea of what regression is about. So in order to do that, we need to first go back to the idea of an equation of a line that you probably knew from algebra class. So we had this equation that y equals mx plus b, where m is the slope and b is the y-intercept. Now first, again, as a reminder, slope is telling us the idea if there's a positive or a negative relationship. So slope can technically be any real number. So it can be negative, it can be positive, and it can also be 0. And then we have our y-intercept, which tells us where we cross the y-axis. So now let's take the idea of what this will look like now that we're working with regression in a statistics class. So we're going to do the idea of what's called least squares regression. The goal of that is to minimize the distance from each point to the line. So to understand that idea, if I look at this plot that we looked at earlier, we said it seemed straight enough. It seemed to have a positive relationship. So on here are 3 lines that are all straight lines and have a positive slope. But you probably would agree with me that one of these lines you like to fit the data better. And it's probably line 3. We like how line 3 tends to go right through the middle of the data set, no matter where I am on the x-axis. It's going right through the middle part. And in fact, line 3 is the least squares regression line. So the idea of line 3 is that it is as close to every single point that it can be at the same time without me having to bend that line. So that's the idea of least squares regression. We're going to look at a slightly different equation, keeping in mind though the one that we already know from algebra class. So we'll talk about what it looks like and what the differences here are for that. So first, instead of y, we have this thing called y hat, and we'll talk about what that is. And that is going to be b1 times x plus b0. And y hat is this predicted value of y. So first, looking up here at this line, that would be those points that are right on this red line are y hat. So that's what we would predict to have happen. As a side note, what y actually then is the observed value of y. So again, for example, if I looked at line 3, down here is where I'd be predicted to be, but then this point up here gives me the actual value. So what I predicted versus what actually happens. So for example, I could predict the price of the house to be $200,000, but maybe the actual price of the house is $190,000. So there's this distinction between the predicted value, this y hat, compared to y, which is the observed or actual value of y. Now we're going to talk about B0 next. So B0, kind of first of all, to match that up to our equation we already know, is the one that's not attached to x, so this is like our y-intercept. So B0 is the y-intercept, but we're not just going to call it that, we're going to talk about what that actually means. So B0 is the expected value of y when x is 0. That's what it would literally mean to cross the y-axis, is that x would be 0. So for example, if I looked at this data set here, you'll notice we actually don't have 0 right on there, but I could look to see, well, where would 0 be? And that could give me the idea of what the y-intercept could be. If you look at our graph above, that's just something to be very careful of when you're looking at a graph, is that this doesn't automatically start at 0, 0. So if you think about, well, x equals 0 is somewhere, it's probably like way down over here. So sometimes this value will make sense for us to look at, sometimes it will not, and we will talk about why as we start interpreting things later. But again, so the idea of the intercept is that our expected value of y when x is 0. Now b1 is our slope, like our m above here. And what that really is measuring is our expected change, which could mean an increase or a decrease, depending upon if slope is positive or negative. So it's our expected change in y when x increases by 1 unit. So basically it's going to tell us as I move over this 1 unit for x, how much am I either going to go up for y or down for y if it's negative. So for each time I move over this 1 block, how much up or down am I going to go? And that's what our slope is going to tell us. Now, we're not actually going to be calculating the slope and intercept by hand. We will actually be letting StatCrunch do this for us. And we will start off with an example in the next video.